Okay, Bismillahirrahmanirrahim. Let's start our class. So, in the previous class, we have started the testing and commissioning of the circuit breaker. Of the release. Okay, so this lecture is in continuous with the previous lecture. So, uh, uh, today we will discuss the commissioning and acceptance test. Okay. And then at the end we will discuss the routine maintenance test. Okay, in the previous class we have discussed the type tests, different type tests. uh, some of the tests were applicable uh, for the electromagnetic relays and some for electrostatic relays. Okay, so now this is the second type of the test, that is the commissioning and acceptance test. Okay, so on the other hand, acceptance tests are carried out at the manufacturer's premises. Okay, in the previous test, most of the tests were performed on the manufacturer side. So similar is the case for here. These tests are carried out on the manufacturer's premises. These tests are very detailed in nature and are done to verify the relay performance as per the, the declared or the agreed customer satisfaction along with the relevant standards. Okay, so as the name revealed that whether these tests, whether the manufacturers, what the manufacturers is going to provide to the consumer are according to the customer's demand or not. Okay, so whether he will accept these protective devices, uh, because if these devices are not according to the relevant standards or the specification as ordered, so the customer will never declared and agreed on these protective devices. So these tests are carried out that whether the customers are agreed or declared on the specific specification provided by the manufacturers. Okay. So the first one in commissioning and acceptance test is insulation resistance test. Okay, so uh, insulation is very important for the productive devices and the equipments. So if a proper insulation is not provided, so it may cause electric shock to the operator. So the proper insulation is to be provided. Initially, all the earth connections are removed from the wiring. Then a 500-volt measure is used to measure the insulation resistance to earth of the current transformer circuits, CT circuits. Okay, measure, measure are the instrument that is used to measure the insulation level, especially for the cable insulators. Okay, so measure are used. In measure, we have a generator type structure arrangement. In measure, we are rotating the handle or the rotor, so it actually provide the mechanical energy to the generator, and in the result the electrical energy is produced, which is going to flow through the insulator to be tested, and by this way a resistance is uh, given by this measure. Okay, so this is uh, the brief working principle of the measure. Okay, it is connected across the appropriate earth links before they are opened. They should be removed after the reclosing of the earthing. Okay, so the ideal value of the insulation resistance is around 5 mega ohm. This is a huge amount, and so the insulation level should be as high as possible. Okay, so different tests is performed for the insulation because the thermal stability of the insulator is also checked, uh, because if the temperature is increased uh, from the outside, and similarly also from the inner side, because if the current is flowing through the cable, and for example 40 degrees C is produced, so we will check it for the for the 90 degrees C, because the outside temperature of 50 degrees C is also add up with inner temperature produced by the flowing of current. So a total of 90 degrees C test will be carried out for the insulation, okay, in order to test its thermal stability. Okay, the measured value of insulation resistance may be used in future to know the duration of the insulation. The measured value of wiring circuits involve grade of insulation and humidity at the site. Okay, so as the humidity is increased, so it will deteriorate the insulator, and it will reduce the dielectric strength of the insulator. So uh, these points should be keep in mind while testing insulation resistance of the equipment. Okay, the second one is the secondary injection test. It is done to ascertain that the relay calibration is correct during an injection of the current in the coil. This test is carried out using the secondary injection kit. Okay, a kit is used in order to verify its calibration, because for any instrument calibration is very crucial. So if it is not calibrated correctly, so uh, how we can verify that whether it is up to the desired standard or not. Okay, so for that purpose, uh, a secondary injection kit is used to verify its the calibration of the relay, and whether it is correct or not. Okay, in early stages it is made up of test blocks or test sockets in the relay circuit, so that connection can be made to the test equipment without disturbing the wire. Okay, so we have not to disturb the wire, and we have to perform some early tests. Okay, so that connection can be made to the test equipment without disturbing the wiring. At present, all the manufacturers provide a separate secondary injection kit that contains modular type keys through which the entire testing is performed. Okay, so that the remaining wire is not disturbed. The third one is the primary injection test. Okay, so it ensures the correct installation and operation of the whole of the protection scheme. Hence, primary injection tests are always carried out after secondary injection test. Okay, so keep in mind that first we have to perform the secondary injection test, and followed by the primary injection test. Okay, the primary injection test involved CT secondary winding, relay coils, trips, and alarm circuit, and all inventing and intervening wiring circuits. Okay, so all these tests will be performed for the relay. This test is carried out usually with a portable injection transformer. Okay, uh, and power transformers are bulky and heavy, so uh, special type of transformer is to be provided for the testing purpose. So such transformers are portable. So these types of the transformer are provided by the manufacturers in order to carry out the primary injection test. It uses local mean supply and possesses several low voltage heavy current winding. Okay. It uses the local means supply and possesses several low voltage heavy current winding. These winding can be connected in series or parallel according to the current requirement. Okay, so if we want to increase the current, we have to connect this in parallel. Okay, because in parallel the current is increased. Okay, this is the example for the primary injection test. Considering that 10 kVA is the rating of the injection transformer with a ratio of 1 can be tuned up to 1000 ampere when four winding are connected in parallel and 250 ampere when they are connected in series. Okay, so if they are connected in series, so we will get 250 ampere. In order to increase the amperes, as I have told you in the previous slide, that for that purpose we have to connect the transformer in parallel in order to increase the current. Okay, so to control the current of the injection transformer, either a tape reactor or a heavy current variable auto transformer is used. Okay, different type of transformers are used for this purpose, like the tape changing transformer, auto transformer. The auto transformer are the single winding transformers. Okay, the single winding, uh, for the typical transformer we have two windings, primary winding and the secondary winding, but in auto transformer we have a single winding. So how it will be managed for the primary or secondary? So you must know that, and single winding is used for both the primary and secondary purpose. Okay, for example, if this is the single winding, okay, for the auto transformer, so this side, these tapings will be considered for the primary side, and this type of winding will be used for the secondary side. Okay, so the use of a reactor for current control is not good, as it causes a great deal of power loss through dissipation. Okay, so there is a huge power loss. So this type of control is not good, is not acceptable at all, because we need such type of the mechanism in which the efficiency is high. By this power loss, the efficiency of the system will go down. Okay, so the fourth type of the commissioning and acceptance test is the tripping test. Okay, so the complete sequence of tripping should be checked from the protective relays to the tape tripping of the circuit breaker. Okay, so a complete sequence of the tripping should be checked from the very beginning till the end. This test is carried out just after the primary and secondary induction test. So as you can see that we are moving in a sequence. We are discussing all these tests in a sequence. So the first in this sequence, the first test was insulation, followed by the secondary and the primary injection test, and then we have the tripping test. So this test is carried out just after the primary and secondary injection test. Okay, so this one is in fourth sequence. During this test, the trip and alarm circuits are not operative. Hence, after completion of primary and secondary injection tests, it is necessary to check the tripping and alarm circuits. This is done by manually closing the circuit breaker contact. Okay, it is important to check that the relay contacts are clean and secure. Further, all flags must be checked for positive operation. Okay, so that the proper enabling of all the operations can be checked by using the flags provided by the manufacturers. Okay, the fifth one is the impulse test. It is specially carried out for the static relays. Okay, in the previous lecture, we have discussed our some tests were performed by manufacturers for the dynamic relays, but this test is especially the case for the static relays. Okay, you know the impulse is a huge amount of the current flowing for a very small period of time. Okay, so the example for the impulse are the lightning and the switching. Okay, so lighting is the external source of the impulse voltage and switching is the internal source of the impulse voltage. So if I draw the impulse voltage, this is the impulse voltage. Okay, this is the peak value, we peak, and we have the time mostly in microseconds. Okay, millisecond to microsecond on x-axis. Okay, so the fifth, when it reaches to the 50% and when it down to the 50% of the peak value, 50% of the peak value. So when it rises to the peak value, this is called the wave front, and when it goes down to the 50% of its peak value, it is called wave tail. Okay, so as per IEC standards, the experimental wave with a rise time of 1.2 uh, millisecond, okay, and a fall of 60 microsecond is applied, and the components of the relay must withstand it to pass this test. Okay, so if the wave tail is flowing in 1.2, okay, from this point to this 1.2, and from this to this 50% in 60 microsecond, and this time is 1.2. So these are IEC standards. So if uh, it obeys these timings, then the impulse test will be passed, otherwise this test will be failed. Okay, the peak value of the voltage wave applied to the relay varies from between 1 kilovolt and 5 kilovolt. Okay, this peak value varies in between 1 to 5 kilovolt. Okay, this value depend on the nature and location of the external wiring connected to the relay. Okay, so these were all about the commissioning and the acceptance test. Okay, and in the sequence of commissioning and testing of the release, we have the third one, that is the routine test, or also we can call it the periodic test, because we have to periodically perform these type of tests. That is why these are called as the routine test or the periodic test. Okay, so and these tests will be carried out in order to check its operation for the maintenance purpose. So if proper maintenance is not carried out, so the life of the protective relays will go down. So in order to increase its stability and its life of operation, we have to periodically check and to perform these routine tests. Okay, so maintenance test is required to ensure that the protective gear senses the fault and operates at the expected speed. Okay, so for all the protective devices, there is a specific time of operation. So if it is not working in that uh, provided operated time. Means it is slow in operation. When a fault occur, it performs its trip slower than the time provided on the rating of the circuit breaker or the relay. So it means uh, the operation is slow. So we have to check that what's the reason behind this slow operation. Okay. At the same time, the same protective gear remains inoperative in case of external or out of zone fault. Okay. So if it is inoperative, so we have to check that what is the reason behind its inoperative in case of the external or out of zone fault. Okay. Out of zone fault means, as we have discussed in the release, that uh, the relay is to operate in a specific zone, because if it is not operated in specific zones, it will trip the whole circuit, so which is undesirable. So for the specific zone, particular relay should be operated so that, and the other relays or the supply to the other equipments should be uninterrupted. Okay, so therefore it is mandatory to carry out routine maintenance tests on protective gear to ensure that the equipment is always ready to perform its duty in a fully discriminative manner. Fully discriminative manner, I have discussed this point, that the relay should be discriminative in such a way that it can discriminate between the healthy portion or the faulty portion of the circuit. Okay. Requirement of the routine maintenance test. Usually, a protective gear does not deteriorate with reference to its age of installation. However, there is a possibility of damage to such protective gear due to many adverse conditions. Okay, so for a relay, a number of operations are given on its counter, and we can see on this counter that how much time this relay or the circuit breaker is operated. Okay, so there may be a case that in many adverse condition it is damaged. So this should be periodically checked, that whether it is working properly or not. Okay. Requirement of a routine maintenance test. So these conditions are: continuous vibration may affect the pilot or bearing of the electromechanical relay. Okay, so the pivot or the bearing in the electromagnetic relay should be properly working, and the continuous vibration may affect these two components. Okay, the pivots and the bearings, so these should be periodically checked. Insulation resistance of the multi-core cable in wiring may be reduced because of dampness in the junction box and circuit breaker kiosks. Okay, so internal resistance should be checked. Okay, because it may be reduced because of the dampness in the junction uh, and the circuit breaker kiosk. So this resistance should not be low in normal condition. Okay. Third one is, there is a possibility of deterioration of the relay ligaments, the relay contacts and auxiliary switches due to polluted atmosphere. Okay. So these reasons may deteriorate its operation. So these should be checked out. Okay. For the polluted atmosphere, for the relay contacts, etc. Insulation may deteriorate because of continuous energization of the coil, which produces heat. Okay. The continuous energizing and de-energizing causes the heat, which may deteriorate its insulation. So this insulation should be checked by the insulation test. And there is a possibility of open circuiting of coils or contacts due to the electrolysis, which causes a green spot. Okay, this is the chemical effect. So the chemical effect, the chemical deterioration also affect the operation of the relays. Okay, so this should be also checked out. The frequency of routine maintenance stress. Okay, so how periodically, how at what frequency these tests is to be carried out. So the frequency of the routine test varies with the type of equipment. However, it depends on the fault history and the fault liability of the equipment. Okay, so there is no fixed frequency for any equipment. It varies with the type. It varies with the fault history. Okay, when it means what last time the fault was occurred on that particular equipment. Okay, so if a fault is not occurred many times, so there is a possibility in the near future that a fault may occur. Okay, so it should be checked uh, with intense care. Certain equipments are continuously checked, whereas other may be checked or tested annually. Okay, so not all the equipments are to be checked on daily basis or monthly basis. Some may be checked on annual basis because the chances of the fault in these equipments are very rare. So there is no need to check it on monthly basis. Okay, rather it should be checked annually. A typical schedule is as follow. Continuous checking, the pilot supervision, the trip circuit supervision, the relay voltage supervision, battery earth fault supervision, CT supervision of the bus bar. Okay, so these are the continuous checking. Okay, so the daily, now the frequency, some are daily, some are monthly, bi-monthly, half yearly, and yearly. Okay, so what are the daily? All relay flags and semaphore indicators must be inspected daily. Okay, so all flags should be checked on daily basis. If a carrier protection is used, then test on carrier protection must be performed daily. Okay, so for carrier protection, it should be inspected on daily basis. Now, monthly, water level of the liquid earthing resistance must be checked every month. Okay, so the liquid of the earth resistance should be checked on monthly basis. Bi-monthly means of every 2 months. Channel tests must be performed bi-monthly. Okay, half yearly means after 6 months. All the tripping tests must be performed every 6 months. Okay, whether it is tripped on the fault case or not. Okay, because there may be some relays and circuit breakers which are not tripped from the many from many time. Okay, so it should be intentionally tripped so that its mechanism, pneumatic mechanism or hydraulic mechanism, whatever mechanism is used, is working properly or not. Okay, because if when a serious fault occur, so if they are not operated because of the very unoperated for a very long time, so it should be intentionally tripped and checked and inspected after every 6 months. Okay, and these are the annual checking. Okay, operating level check, the sensitivity checked, and tripling angle check. Secondary injection test on more complex and important relays. The insulation resistance test, which is the one we have discussed uh, on number one. Okay, on series serial number one. And the D is inspection of gas and oil actuated relays and inspection of the battery biasing equipment. Okay, so these inspections uh, should be performed annually. Okay, so all that was about the commissioning and acceptance test, and then we have discussed the routine maintenance or the periodic tests. Okay, so in the earlier class we have discussed the type tests. Okay, which were performed by the manufacturers. Okay, and now these commissioning tests should be performed, so that whether these are according to the customer's specification or as per their demands or not, and whether they are meeting the IEC standards or not. So if they are not meeting the IEC standards, so these are not acceptable. Okay, so a proper insulation testing, a proper secondary injection and primary injection test, and the tripping test should be performed. Okay, and this impulse test is very important because lightning, because these the protective equipments are exposed in switchyard in the open air, in the outdoor environment, so there is a chance of lightning. So this lightning is actually called the impulse voltage, and an impulse test is to be performed. So for that purpose, uh, if the rise time is 1.2 millisecond and the fall time, the wave tail time is 60 microsecond, then it means this test is passed. Otherwise, if they are not meeting these requirements, so it means this test is failed. Okay, in routine test we have discussed that some test is to be performed on daily basis, some on monthly, bi-monthly, uh, half yearly and yearly. Okay, so a proper operator is to be given the duty in order to perform these tests, and a proper report is to be maintained, and there must be a record keeping for all these tests. Okay, so that a fault history is also uh, available in the power station. Okay, so I hope you will understand all these tests for the commissioning. Okay, and acceptance. uh, that's all for the moment. Thank you.